All right, let's do a few of these guys here. We have tangent. Tangent, we know at the point of tangent C is perpendicular to the radius. We were told that CD was equal to 4. It does say that C is the center. That's what the circle C is telling us. It says that AB is equal to 10. I know that this is 4 because it's also the radius, and I'm looking for CB, which means what I really need to do is a little bit of Pythagorean theorem. So I end up getting the square root of 116, which is approximately 10.77 as our answer. All right, here we're finding the shaded region. So first of all, it says we have a side length of 6. And one thing we need to do is we need to figure out what the area of the pentagon is, because ultimately we're going to take the area of the circle and minus the pentagon from it. And that'll give us our answer, which means we need to know some degrees here. So my central angle here is 72 because I would take 360 divided by 5. And if I divide that in half, I would get 36 degrees here. And then I would want to use, 6 was the whole guy, which means this 3 would be the half guy. And if I want to find the height, which I would need to use the tangent of 36 is equal to opposite over adjacent, and I solve for x, and that is equal to 4.13. So for the area of my pentagon, I would have 1/2 of 6 times 3.13. Is that what I said? Nope, 4.13. 1/2 of base times height, and then of course I would want 5 of those. So when I do all of that mess, what do I get? I don't know. 3 times 4.13 times 5 is 61.95. Now for the circle I need this. So I have choices. I have 4.13. I can use Pythagorean theorem right here, but I can also use sine, and I prefer to use sine because it will be a little bit more exact, because I'm using sine of 36 is equal to the opposite over the hypotenuse, and it's all whole numbers in my calculations. So then this is equal to, when I am done, 5.10, and the area of the whole circle is pi r squared, and since this is already a decimal approximation, I might as well just say 5.10 squared, and then multiply that whole thing out by pi, and now I just have one nice little decimal to look at. I'm going to subtract my area of my pentagon, and I do get 19.76 as my answer. Let's go ahead and try a couple of more of these guys here. Let's try this one here. Circle B, so that is the center. AC and DB are perpendicular, which means that these are also bisected. So it's similar to number 1. AE is 4, BE is 3, and we are looking for BC. Well, I'm going to go ahead and find AB, because that's a 3, 4, 5 right triangle, a nice little Pythagorean triple. And since that is the radius, BC is also the radius of 5. Now I'm also looking for AD, so that means that this is also a radius. So if the whole thing was 5 and this is 3, this is 2. And I would need to use Pythagorean theorem to find that. So 4 squared plus 2 squared is equal to AD squared. So that's 16 plus 4, so square root of 20, which is 2 root 5, and that is equal to AD. Decimal approximation is 4.47 for all of you decimal fans. All right, let's go ahead and do one more of these guys. It says this is equilateral. It says AB is 6, and we're finding the area of the whole triangle, sorry. So this is 60, which means that's 30, this is 3, this is 6, and this is 3 root 3. So the area of a triangle is 1/2 of the base times the height, which is equal to, reduce, to 6 root, did I do that? No, 3 Sorry about that. Reducing the 2's changes that to 3. So 3 times 3 is 9. Root 3 is the answer, which is approximately 15.59 for the decimal. All right.